of the anode side. This is one that's dealing with the filament on the cathode side. See, Mr. Phung can be tricky like this. What I just did right here.
Copper.
Huh?
On the anode side.
Copper's on the anode side, dealing with the rod.
So just remember, for your tube, you are running an electrical current through the entire tube, right? So the tube does need to be able to direct electricity from the cathode end to the anode end, but electricity does not stop at the anode. It would need to travel into the rest of the circuit as well. So how's the electricity going to travel out of your anode? Well, what material are your wires made of? Copper. So that's the purpose of the copper in the stem of your rotor, right? It takes the electricity, passes it down through the rotor, and then into the rest of your X-ray circuit, which you will learn about next semester.
I thought the electricity came from the cathode itself.
Correct. So your electricity, your electrons will come in from the cathode side, and they will exit out the anode side, and they'll go into the rest of the circuit to make the loop once again.
Okay.
Right.
So is copper a conductor or an insulator?
Conductor.
Okay.
Very good.
Henry Oak. Which of these components are needed for the production of X-rays?
Red, source of electrons. Blue, target. Yellow, high voltage. Green, all of these.
I almost made a mistake.
I did.
Alright, still needs one more person to answer.
Yeah, two more people, right? Did you drop out?
No, I'm waiting. Oh, there we go.
Yes, all of these. See, this is the mistake I would make. I'd read this really fast and be like, oh, this one right here. I see it.
Yep.
Yeah, so that's why you gotta read every single one, guys.
But because I knew target and source, I didn't know it was high voltage. So
High voltage.
It is always high voltage.
You're working with kilovoltage in X-ray.
KVP.
KVP.
And the peak specifically, the highest.
Henry Oak on fire, okay.
Ooh.
What is thermionic emission? The cooling off of
She said
electrons
good
from the
question.
cathode filament,
Oh.
the relaxing of electrons from the cathode filament, the boiling off of electrons from the cathode target, the boiling off of electrons from the cathode filament.
Oh, I marked the wrong one.
That's a Mr. Fung question right there.
I marked the wrong one.
Read to the last
I marked the
word.
wrong
You're giving me a
one.
bad reputation here.
Yeah.
Mr. Fung.
I
So,
marked the wrong
right
one.
there, that last one right there, that filament.
Yes.
Not a target, we don't have a cathode target. So, yeah, read carefully.
Yeah. And don't hurry to give it the answer.
Girl, don't be like this then.
What is the envelope made of? The envelope is made of tungsten due to heat resistance. The envelope is made of iron due to heat resistance. The envelope is made of glass due to heat resistance. The envelope is made of borosilicate. Oh my god, not
You can do
it. Borosilicate glass due to heat resistance.
Oh, then I marked the green before the yellow.
Oh my
Sorry.
god.
Oh.
10 people got it. Okay, so this one right here, that's a little
Yeah.
trick question right here. But if we're being specific,
Yeah. I should wait till you read all of them.
Glass would have been a good
It's
example.
not
for what you
technically
were talking
always
about
the
earlier.
borosilicate,
Mm.
though,
That's true.
Like
It would not
instead
be
of
made of
marble,
tungsten.
glass is best.
because there's two.
Water.
It's not always. It's not necessarily always made of borosilicate, right? Because there can be a metal envelope.
So we cannot use a metal envelope.
Okay.
And the reason is because if we use a metal envelope, metal being a conductor will also attract electrons towards it. And that's also the problem when you have a glass envelope that has residue on it, because then you will end up with arcing, where the electrons, instead of going straight to the target, will take a detour and jump to the side of the tube and then jump over to the target. So now you have electrons hitting the glass when it should be just going straight across. Does the book mention a metal envelope?
I'm pretty sure it does. But
Do you know if it was lead?
because I don't know. It's, in my
Okay, guys, I
notes,
have another
Your notes you
question.
have?
in my notes that I wrote
What
with
is
the book, it
inside
said that.
glass
So
envelope?
Everything. Oh,
Yeah,
vacuum.
we-
The vacuum.
Making mistake.
Why do we need a vacuum?
No air.
But why?
So it doesn't like catch a fire?
Because we don't want electrons going in the fire.
Yeah, we want them to be sucked.
What did you say? There's two reasons.
And then also because the air
This is glass.
will get in the way of the electrons.
Okay, okay. Don't make me proud.
What was the other one?
Combustion.
Heat equals fire. Heat of air equals fire. That's what I wrote in my notes.
So,
You just pulled the receipts?
he did. So, I am mistaken there. So, yes, there is a metal envelope. I was mistaken.
What is the
Extra credit for the whole class.
So the book does not specify what the metal envelope is made of. It states that the purpose of the metal envelope, though, is to help avoid the arcing problem by creating an even amount of electric potential so that it won't go off to the side or go straight to the target instead.
Wait, so
Okay.
Whenever that the tungsten gets stuck on just the something.
Right, so if you have your glass envelope and you've got residue stuck onto the sides of the glass envelope, it may attract the electrons to jump to that first
Oh yeah.
before going to the target.
But Mr. Fun, what are they normally?
But yes, the majority of your tubes will be borosilicate glass.
Make sure.
Yes. So metal is an option, but that is going to be much less common. Thank you, Cody.
no, man, I just wanted to make sure.
Did he actually
You did.
Which side of the tube is negative? Mr.
There's
Help
no
up
trick
to this
in
you.
This is the trick in it,
I
I
was
know.
not even paying attention.
Oh, I remember this question. I was going back and forth. I was like, wait. Oh, I got one person. Oh, no, I didn't. Maybe no. That's good.
Very good.
Mr. Fung, was that you?
What?
The
No.
what? No, you
No,
actually
no,
got it.
no.
I thought you said you were doing all wrong.
I thought about it, but I just decided I'd try and go for a.
You see that? You see that you little stretch? I thought about it.
I'm gonna try and go for that 30 question streak.
Four.
But I'm gonna try and answer slowly so that other people have a
Where are
chance.
the stators placed? Outside the envelope, inside the envelope, on the cathode side, inside the collimator. Yes, guys, outside the envelope. And why is that? For the people who
Oh,
answered
this,
this one.
The magnet.
it's outside and
So they can
outside.
rotate.
But we saw.
But why is it on the outside?
We
So
see
they
it.
can't touch.
Why?
So isn't it inside the, we see it inside, don't we? Right, this is the
the
anode is inside the
No,
envelope.
the vacuum. Oh.
Because if they were on the inside, yeah, it's the vacuum. You want it to be closed.
Correct. So stators are on the outside, rotors on the inside.
So
They
yeah,
do
for
not
the
touch.
people that did this one would be the rotors.
What about ceramic tubes?
You mean the outside the glass
What about
envelope?
ceramic?
But do,
When we
Looking
say
at
envelope,
regular
it's also talking about the
and it
glass
says they
envelope.
have glass, ceramic,
the,
and even
the
metal.
main envelope one.
Why is it on?
I'm
So
not
there's
familiar with
there's a
ceramic
house.
tubes.
So the
I'm trying to
vacuum.
Yeah,
find what
there's
they're
the glass.
together, but it says that
Oh.
right in charge.
So there's some other,
So that-
there's
like-
some,
This was
they're
magnet.
also talking about the case.
Stationary.
You're talking about
Well,
another
it's
talking
glass,
creating a magnetic.
there's another glass inside the
But the
glass case.
stators are on the outside.
Oh, I have to look at that. Okay, let me check. Let's see.
What did you ask? You said why again? Is that what the vacuum? So you want to explain that better, Charlie?
Right, so we're trying to maintain a vacuum. So the idea is that we're gonna have our spinning part on the inside of our glass, right? But we can't have a whole bunch of machinery there because machinery is gonna have leaks, you're gonna have air get in. So instead, we're gonna use an electromagnetic motor and put the magnets on the outside. So magnets on the outside of the glass, and then the spinning part on the inside. So that way we can spin it without ever having needing to break through the glass to touch the spinning part. We're just gonna manipulate it from outside the glass.
XOXO.
And then outside this is the envelope glass, sir.
We're talking about outside the glass envelope, yes.
Just
What are two filaments called? Deuce focus, dual focal, double focus, dual focus.
I feel like you're being meaner than I am.
Why? I think that's not hard. Some sound weird, like how you said deuce, right?
oh now dual focal and dual focus.
See, like nobody picked deuce, so I'm
I
happy about
took dual
that.
focal.
Double sounded okay. Dual focal was close.
Yes, so then you have the
Dual focus. Yes, guys. Dual focus.
I couldn't find the material.
Mr. Phung, you think I'm meaner than you? What?
Definitely not.
You, thank you. Thank you.
What did you say? I said definitely not.
How long are the filaments? How long?
I've never seen this in my life.
That's why I said you gotta know the amounts, guys.
Yeah.
you're going to 6 millimeter. Yes.
The little amounts always matter.
8.
Hey, but look,
15
Mr. Phung,
millimeter.
you see how we put it? I'm so proud right now.
Yeah.
That's a lot.
Most of them are still getting it.
Okay. Yeah.
So 7
That
to
was
15.
close. I get it because it's like 16 to 20, but no, 7 to 15, guys. This one's too soon. XO coming up, okay?
Sody.
How wide are the filaments?
Oh, now not big enough.
This one's a little mean, I ain't gonna lie.
This is a little mean.
This one is a little mean.
I think it's you.
Hey, I'm so proud of them. That looks good. Yes, this one right here, guys. And like I said, these amounts do matter. He will ask you. These. That was close too.
Mr. Phung's
That was
like,
super
please
close,
stop giving
Mr.
us
Phung.
passes away.
Can't use that question. Can't use that
Yeah,
question.
he's like,
Can't use that
comfort,
question.
like-
I'll still use it.
What? You're gonna use some more?
Maybe.
Why are you nice after like
No
this?
promises.
Ooh, this one's a mean one. Leakage radiation must be limited to less than. Yeah, did I not specify? You
did
have to
specify.
know these. We just got quizzed on these.
Be like, y'all did.
Yeah, y'all did.
But y'all ain't learning this. So
Yeah.
I'm teaching you right now, so it'll stick in your head. You'll be like, okay, I know what you're talking about. That's a lot of people, Mr. Phung. I am so
That
happy.
is, I'm proud of them, yes.
I remember it was a very specific number, and that's the.
Okay, why is it not this and why is it not that? Because it's supposed to be 100. So,
Why is it not that?
because this is 102, this is 101, so it's supposed to be 100. These were both 100 and right.
Right, so know your limits, right? Leakage radiation, if you're using the old school units, it's gonna be 100 milliroentgens per hour. But if you're using your SI units, right, your new school units, it is 0.0258 millicoulombs per kilogram per hour.
And I'm doing this.
So probably
for
you
y'all.
should have gone with the
Scientific.
So
millicoulomb
yes,
per
pay attention to your units.
units.
Your units will help you a lot of times.
Because that's the only unit that's correct.
Mr. Phung got a question.
Oh,
guys.
Mr. Phung, you already on it.
You lost the streak.
Oh, no. I think Cody and I are neck to neck in terms of our streak.
11.
What is the atomic number of tungsten and its melting point? This should be easy.
Okay, one observed term, okay, 74, 78, 78. Thirty, 74.
Yes. There you go.
Yes, 74. And then the melting point is 3,400 Celsius. These ones were two of the tricky ones. And how many times is what is it called? Whenever it's warming up, it rotates?
3,400 times.
Yes. What is the unit? Or what is that called? Unit?
Minutes.
RPM.
Good. So rotor spins at 3,400 RPM for your general X-ray tubes. Right? You also have special X-ray tubes, specialized ones.
10,000.
That's right. They can go up to 10,000 RPM.
You can burn it.
Okay. What is the focusing cup made of? Y'all should get 100 on this one. Do not disappoint. It's literally on the board.
Don't say that.
Well, you have it up there.
Yeah, but what about the people with poor eyesight? You can't make it out over here.
Hey, you chose to sit in the back.
Like me.
Oh,
Like
it's okay.
I shall remember that in my older age.
So, tungsten, it would have been the filament.
Target.
The filament or the target.
Mhm.
So you guys were almost there. A little bit close.
People
Yeah,
can-
that's nickel. That's for the focusing cup. Mr. Phung, you go. What happened?
I'm answering them at the last second, so I'm only getting half the points.
What are the two primary designs of an anode? Me and you just talked about this.
I think I hate this chapter.
It's
not that bad. It's just pig reds.
Mm-hmm.
Red is the one.
Watch me.
Thank you
Phung,
for
with
your
the
hints.
ceremony. I'm so proud of my eyes. You read.
Yay,
Not
everyone
yet.
did.
Oh, I don't read that.
Read every answer.
That's right. Read every answer.
What type of anode is the older design? Charlie, you should know.
It's definitely rotating. It's definitely rotating.
I think everybody should be fun
That's on TV talk. It's okay.
Everybody knows what you mean.
Okay.
Yeah,
Stator.
that's the fun.
What is a
Mark
stator?
that on purpose.
Part of the inductor. Part of the induction.
Induction.
Rotor and stator are the part of the
Okay.
induction motor.
And then rotating is the newer design. We use this one more. But why?
So that the heat is generated, not generated too much.
To spread.
So the heat doesn't hit one spot, it hits multiple spots. Cause it's rotating.
Which type of anode design is only good for low exposure techniques? So we just talked about this.
Yeah, like
And you can thank Carol for that talk.
What has heat got to do with low exposure?
Stationary.
What has heat got
Alright,
to
so
do with
Samantha, can you explain this answer for us, please?
Let's see. Double nose. It is. See how to explain it.
So think about heat.
Well, right. Okay. So I feel like the rotating one, and how you guys did the thing where they were kind of like interchanging and everything. I felt like that would kind of help it. Where if the stationary one was there, and let's say if it was hey, low exposure, kind of low heat, that can kind of handle that better if it was stationary. But if there was like a lot of heat, I feel like the rotating one would be a better option
So
for
a
like the
lot-
process.
A lot of heat, right? So
Yeah.
A lot of heat would be good for which one?
I think a lot of heat would be good for the rotating one.
Mm-hmm. But look at what it says up here.
Mhm. And so,
So if it's high exposure, it'd be hotter.
Right.
So the hotter one would be for rotating. But
Rotating.
since it's
Yeah.
low, that
Er-
means it's not as hot.
Correct. So it'd be good for stationary.
Mm-hmm.
Okay.
good.
You guys get that?
Yep.
What material is used for a rotating anode?
That's you.
Alright, that's enough.
I'm not missing no day. I'm not making up no day.
Good attitude.
I know that's right, girl.
Wish it was like my class.
She would get all y'all.
You heard Mr. Phung?
Yes, I'm like, no, I'm not gonna say that.
Alright,
Every time I think about it.
yes, let's do it.
Mhm,
Where's
that's what I said,
thorium?
no.
The filament.
Phil, you guys hear me?
Mm-hmm.
Where's thorium? Where's nickel?
The cup in the
Where's
capital.
barium?
Patient care.
Patient care for the barium.
Patient.
Patient care.
Using a stationary anode, electrons hit in this area called stationary. Yes, focal spot, also called focal point.
And what's it for rotating on the horn?
Focal track.
Give a second. Give it a second.
Anybody get a question on that? I think we do. I think I did.
Have you ever seen a sphere before?
I think I did. Having a slight small target does what to image quality? Angle. Let me say that, sorry. I think I didn't check that. Small angle.
Very good.
Mr. Phung?
I think it's,
Yeah,
sir,
I
please
think I didn't
explain
take your
this.
job. Complain.
Sir, please explain
don't know.
this. How
Do you
we
mean-
slight
you
target
want me to
is
explain it?
what to the image quality. Yeah, Elia, please explain it. Sorry,
Okay, see, like she was gonna ask
Sorry,
Mr. Phung. I'm over
I'm
here
so
feeling
sorry,
like-
I
After.
good,
I think we should do it.
out of habit.
Oh, you wanna do it after?
Yeah,
Okay.
after,
So,
cause it is a lot.
okay, I'll explain it to you after we're done with this, okay? Using a rotating anode, electrons hit this area. So there you go.
That filament.
Mr. Mike, you think I'm being mean? You think I'm being mean on my questions?
Some of them were
The
like,
diameter.
The first
and
You got Mr.
length
Funk
and
there.
That was
all
too
that.
small for me to see.
Yeah, that's
Okay, guys, hold on, wait a minute. Okay, using a rotating anode. So that means what's happening? I want to ask you guys, what's going on? It's spinning, right? Okay. Focal area, that might have sounded good, but it's more of like a track. Like think about you running a track, right? You're running in a circle, right? So this would be the better answer. Filament. What side is the filament on?
That's what
Cathode side, right? So it's not going to be anything with the anode. And then what about the focusing cup? I need some energy in that one. Where's the focusing cup?
I thought it was at the, no?
No, it's a
Cathode. Yeah, it's at the cathode
Focusing cup.
side. So you could cross this one out. You can cross this one out right here, right?
focusing cup collects the electron, doesn't it? The electron is heading to the focusing cup,
And
right?
it condenses.
The focusing cup should be in the anode side, right?
But the electrons
It
hit
is on-
what part
it is on-
of the rotating
on what?
anode?
I don't
We're
know
looking
what
at,
she
we're,
said.
right now we're looking at the rotating anode.
But isn't the focusing cup in the rotating anode?
Oh,
No.
No,
No.
it's on the cathode side.
yeah, that's okay, that's it.
It surrounds the filament.
So these two right here
It sits
are
in
on
the
the
cup.
cathode side.
This is a focusing
It
cup right
sits in the
here.
cup.
It is like a sushi.
It's a sushi.
Why is it so
Place
funny?
thicker anatomy near the what? And what is this called when you do this?
The anode
Yeah.
effect.
Okay, good. See, look at
What's
me.
that?
They're gonna do good on this test. I hope so. I think
Well, I mean, I thought you guys were gonna.
Why, how come I didn't listen to
You
you
guys were doing
and
okay
yeah,
on your
everybody
own.
else heard? I
The
don't
first-
remember
first
this.
PRE you said?
It's sticking out of me as
What do you mean?
You guys were doing okay on what? What completely?
Oh no, they're covering. They were covering PRE one in their review course.
Oh,
but like
we did good on the first PRE text, right?
okay, so why did
Keep
you
it up.
place the thicker
One more
anatomy
time.
on the cathode side?
What do you mean by thicker anatomy first?
What does?
What do you mean by thicker
Like your
anatomy?
stomach is thicker than your arm.
So like for example, I like to use the foot because it
My
just
baby.
makes sense. So when you
I erased your foot.
my beautiful
see,
foot.
you could use that.
Here.
Yeah, we have-
There you go. Here's a foot. Here's a foot. Here's a foot. So,
Okay. Okay.
so, is this thicker, or is this thicker?
Jane, put your mask on.
This one's thicker, right? This one's thinner, right? So, is this gonna be more radio dense or sorry, more radio dense or less radio dense?
Less.
Is this more or less radio dense?
More.
So, if I was using the same X-rays for the entire foot, how would this look compared to this?
That would be.
This is more black or more white?
More black, sir.
And this is
More white.
more white.
Pause.
So my foot is gonna look black and then it's gonna look white, right? It's gonna look kind of weird, right? It's not gonna look even. So, what can we do? Well, we can take advantage of the fact that X-rays are not even. You have more X-rays on one side of the tube, you have less X-rays on the other side of the tube. Which side of the tube do we have more X-rays on? Cathode side. Which side has fewer X-rays? Anode side. Do you all remember the little line assignment that you all drew out?
Yeah.
Right? So more X-rays on the cathode side, fewer X-rays on the anode side. So, if I want to make my image look more even, do I want to put more X-rays on the thin part or the thick part? On the thick part, I need more X-rays to go through more tissue. Do I want less X-rays to go on the thin part or the thick part?
Less on the thin part.
Thin part, right? Not as much tissue, I don't need as many X-rays to go through. When that happens, fewer X-rays here, more X-rays here, then the image looks more even as well. So, which side of the tube should be on the thin part? Anode, because there's less X-rays on the anode side. Which part of the tube should be on the thick part? Cathode, because there's more X-rays on the cathode side. So, thicker anatomy goes on cathode side. Are we okay?
Thank you, sir.
Star.
I like those shoes, Mr. Fun, the ones that you just slid in and let's go.
Thank you.
Some of the times they're already tight.
Okay. The amount of heating the tube can take is measured in. I should have put that. I should have
I give up. I give up.
Why'd you give up?
Because you don't know anything.
Don't give
But I will know it by
Shaheen,
Friday.
don't give up. Open it back up.
Yeah, don't give up.
So,
It's
on
okay.
an exam. Okay, let's just use this as an example. On an
I
exam,
turned off.
let's say that, no, keep it open.
Promise that battery is
Keep
not
it open.
done.
It's done?
Yes, actually promise. That.
Oh.
You want
Okay,
to turn?
so that's-
Say your-
I thought you were
But you
here
got
to
your
get
phone,
period.
right?
Okay, but alright, let's say that you're taking an exam. In the first 20 questions, you literally do not understand any of them. Right? What do you do?
Yes, I'll.
Flag them, come back to the
Yeah, yeah, that's what I do.
See my way out. See my attack for the next. Like,
Right?
you either
So,
know or you don't.
number one, you realize that you may have studied for the wrong class, right? But number two, even if you don't know anything, there's nothing wrong with guessing on this exam, right? On the registry, you are not penalized for guessing. So just put, if you don't know, just put C. Just put C. Right? 25 is still better than 0.
Or like what I do for Mr. Fun, he probably noticed what I do. I always go to number 1, and I look and I'm like blanking out. I'm like, I don't know what that is, and I always go to the last one.
I've noticed quite a few of
Yeah,
you do that.
that's what I
Right?
do.
You notice me doing that? I don't
I
know
did
why,
that
because
today.
I used to
That was the
anxiety.
first question
I get anxiety before my test, and like I look, I'm like, I don't know what number 1 is.
No, I don't even like vlogging.
So when I go to the
That's
last
what I
one,
do
I'm
for
like,
you.
confidence back up. I know what I'm talking about.
Good.
I find another question with the answer in it.
Yep, there you go.
All right, great. So back on track, guys. Start
So-
back on track.
Focal
HU
time?
is heat units. So we measure in heat units. HU. You use either one.
Which
one? Which one? So I'm saying he could use HU or he could say heat units.
Oh, it stands for. This is a lot like Mr. Buck's test.
Well, oh my gosh, well, thank
Wow.
you. That is actually
What
a
a compliment.
compliment.
That's
Yeah, that's actually a compliment.
That just
I
means
thought
you're
it would be
meaning.
easy.
It feels like it is. It's very fun.
What is the correction factor of a single phase generator?
Oh,
Oh, this is a Mr. Phone question.
This is the Mr. Fun question.
No, I have them all though. They're all on
Because there
there.
are 4 of them that have to learn, right?
Very Mr. Fun one.
Yeah, because I already know. I know what Mr. Fun gonna ask you, so I'm the cheat code right here. Okay, easy way to remember this, guys. Easy way to remember this. So it says single. What does single mean?
Me by myself.
Me
I'm
by
single.
myself.
Dang.
I'm single.
I'm single. I ain't with
I'm by
nobody.
myself.
Hey.
So 1.
You ain't seen
Me, myself, and I. I'm single. It's me. 1. That's how you can remember it. Single me. Just
Single me.
Yeah, it's just me.
So we got that one. Okay, so what's 3-phase 6-pulse generator?
Oh shit, put the wrong one.
See, red. 3.15.
Go with the 3.
Bro, I don't know who you asking. I do not know. The Rad Dream Team.
That's why I said
It's a red dream.
3 is nice to like you never use a 3 in these. There's not gonna be a 3. There's always gonna be the
You get
1
it?
in the first part. So I'm letting you guys know already. There's gonna be a 1 point something. There's not gonna be 3. That's too big.
35, 12 is.
But isn't there another one that says?
1.4
So we
plus.
have one.
The
We
12
have
plus.
another one that says this one.
12 plus.
That's 12.
Yeah.
That's a 12.
This one's 12.
Nope. That's not.
Well, you'll see.
It is
We'll
not.
see.
The
I know one was
1.30.
If not, it's 41.
Is it?
1.30 is 12 plus.
Really?
I'm doing this because it's very like unique.
I'll be
stuff.
down.
This
That's what I
one
say.
now
It's
should
not
I don't
fix
see
it.
that.
Yeah, I'll go for 1.41 also. It's good.
What? 1.14?
Tell me right.
2 is ruled out, 4 is ruled out.
That's why I'm doing this on here so you guys will remember. You know.
1.41.
You see this? Why you gotta stop playing? I don't even gotta tell them. They already know.
Very good.
I'm so happy
So,
right now.
so sunny.
1.35.
Watch
Damn,
like
Cody.
math.
Catch up, bro. You're bullying us.
Right now, I want you
This is
guys
funny, this
to
is
write
funny.
down what you already know. So you have single phase, right? What is that?
One.
Write that down right now. I can do it on the board.
What's that?
Single phase.
I don't know. I'm just laughing. I'm not laughing at anything.
You can take it off on Monday.
3, 5.
So there are two. So it was a single phase, one pulse, just one pulse.
So single phase is either gonna be half wave or full wave.
Okay.
1.45.
As opposed to where they have the pulses.
So that's what we know so far.
There are no pulses with single phase.
What is the correction factor of a high frequency generator?
5 is out, 5 is out, 4 is out, it's 1.45.
What is it?
Okay. Yeah, I do. 1.45.
Dude, she sold me on that one. That was with such confidence.
I know. Look, she was like,
Better
not that
wish
one, not that one.
Bro,
not that
even
one,
if it's
not
wrong, like I'm not.
You're so confident that I actually trusted her.
Mr. Fogg, you see how?
You gotta think shitty.
Swear to God, I swear to God, I did not know that one.
She said it so confident. I was like, okay, I'm going to
Yeah, I was like, that's gotta
So
be
just
right.
remember, right? Ms. Hawkins earlier
She
said
said that was too high.
the first
Yeah.
number
It's 1.
It's always one.
is always 1.
Uh-huh.
So it's just gonna be
All you need to do is memorize the numbers that come after.
That's what she said.
Correction of high frequency. High frequency.
So I wrote these on the board. What is the equation?
Man, you know you wrong for this.
Oh.
How am I wrong for this? This is what he gonna give you.
We are remember this.
What
Like,
is it?
yellow is the one.
Yellow.
Alright.
Because the correction factor.
So please don't say yes. Don't say it out loud.
Oh no,
Please
It's
don't
too
say it out
late.
loud.
sorry.
Right? I'm happy that you may know the answer, but
Eliminated.
Okay, so it's KVP times
You scared me,
MA
bro. I was like, no way I
times
clicked that.
seconds times correction factor. But it also could be mass. It can already be together.
Yeah.
Monty, can you say that one more time?
If you gave up, you wouldn't have gotten this question right.
You would have.
You wouldn't? I mean, you
You
wouldn't.
would.
don't
Wait.
give up. I mean, don't give up. There may be easier questions. There'll be easier questions in the future. Don't give up.
I don't believe
See?
it.
Now
Trial
Mr. Fogg is
above.
coming back. Y'all better not let him win.
I would hope you.
This is the math though. The KVP is 80, the mass is 2, and the seconds is 5. And the type of generator is single phase. Find the heat units.
You have a lot of faith in us.
800.
That's why I told you that.
800. Sorry, sir.
What was it?
Sorry, I probably didn't put it. I think it was 30 on them. 30 seconds. I think I put 30 on them.
Oh,
I didn't get the answer. I just picked it.
Hey, don't matter though. It don't matter though. So, what did we do?
I just did 80 times
Yes.
one.
No, no, back. Hold on. I'm gonna ask Charles. Charles, what do we do?
You just multiply straight across.
Okay, so you do what?
80 times, 2 times,
all right. So
2 times 10.
Times what?
single phase 1.35.
No,
No, one
single
times
phase.
one.
Single. Yep.
Times one. I just guessed it, but yeah, that.
I'm just making sure that we get the concept.
all right. So everyone,
80, 80's too
I'd
much.
like you to listen to Melody. She has a trick for you.
Oh,
Go ahead.
okay.
I just multiplied 2 times 5, which is 10, and you just added 0 to the 8.
Yeah.
8
And then
That's right.
What if 5 was 7?
Then you would have
Then it'd be
Right.
14.
Yeah.
so when you see single phase,
What is that?
even though you didn't know it's one, but whenever it comes to the
What is
math,
that?
just know that you just gotta multiply these.
That trick only works for.
I just
That's
said
what I'm
80
saying.
times
So,
one.
right? So the trick that Melody used, right? Instead of just going 80 times 2 times 5, which is going to be difficult, remember that you can change your order. You can do 2 times 5 first. It's a lot easier to multiply by 10.
I just guessed it.
That only works for these numbers, right? What if 5 was 7?
Right. If it's different numbers, then it'll be tougher.
It'll still be easier because you have smaller numbers to work with. But like, I think what she's saying is she didn't want to multiply 80 by 2
Oh.
to get you 160, then multiply that by 5.
Would you use a
And
calculator
do
for all
3
the tests?
times.
Yes, you can use the calculator for the test.
But no.
Well, yeah. What,
Equations.
so he was saying if it was 7 instead, it's still going to be the same sort of order, or you can do it that way because it's going to be easier.
Just do 80 times 7 gives you 560 times 2 gives you 11,200.
That's a little too yellow for me, bro. I'm sorry.
Alright, you guys ready? Calculators?
Nope, we're not ready.
What the?
Hey Siri,
The
multiply.
KBP is 90, the mass used is 10, and the type of generator is high frequency. Find the heat units.
Should have learned this before, so we can have a calculator.
She said
I said, write these values down. Like Mr. Funk's like, I have to pay him to do this.
Multiply 90
Bless
times
you,
10
bless
times
you, bless you,
1.45.
It's 1,305.
Oh. Thank you.
Too late, though.
Oh, I got it.
That's my bad, guys. You
Look.
guys aren't wrong. It's my bad. I was supposed to put longer time on these, and I accidentally.
No, I think that was Jay's or John's.
John's?
Jay's?
the next
I don't know, whose phone was that?
Whose phone was that?
It's the last one.
I'm right here.
Oh,
I was
I
like,
don't know.
he
whose.
should've-
I just want to make sure you guys understand the concept more than answering right. Honestly. So, we have 90, right? We have the mass, so it's not separated. So we just do 90 times 10. And then we do the high frequency, which is 1.45. Yeah, got it?
Yes, ma'am.
Yes, because I was not.
You broke my streak, Aaliyah.
What happened?
I didn't pull out my calculator in time. I underestimated your answers. I was like, okay, I know it's gonna be around I know it's gonna be around 1350, and the answers come up. I'm like, wait a second. All of these are around.
You really thought.
What did you?
You want it all 13 or 4, 5, and 6, you can go.
How did you eyeball 1350?
900 times
The
1.5.
KBP is 85, and the mass is 6. The radar we use is a 1.5 grid with 40-inch SID.
We don't care about you.
With high frequency, find the heat units.
Times. Hey, wait.
Just record that.
It honestly doesn't matter on this. Honestly, I'm just gonna try to show you guys what.
But what happened to the single unit or double unit or nothing?
All right, guys, look.
Tell him first.
I'm still
I literally
surprised they got it.
tricked
That was a guess.
That's
That's what you
still
call a
fine.
guess.
This is
I don't
fun.
care.
I was like, this could be
Alright.
about this.
So guys, he will be putting other stuff into the
Yeah, this is
equation.
not required.
I'm telling his secrets. Are y'all listening?
Yes.
I'm telling the secrets. So,
I'm sad
why are you sad? 'Cause you lost?
now. I was just
Okay.
trying to go for 30.
So, we got the KVP. Is this important?
Yes.
Good. Mass.
Yes.
Is that
Important. Yes.
Okay. So, what do we do with these two?
Multiply.
Multiply. All right. Does this matter?
No.
No.
Does this matter?
No.
No.
Does this
High
matter?
frequency,
Yes.
1.45.
Which one?
Okay, good.
What's they get 100 on your son was like, ah! I did that. Rugrats, okay.
Woo! Oh, I came back on that. There was one question put you up there. That's me.
What are you looking right at me, bro?
Cody? Is that Cody?
Yeah.
Cody?
Was it an accident or?
Good job, guys.
No, I
I'm
did
so
that.
proud right now.
Good job.
Sody.
Who's Rugrats? Is it you, Shemik?
Huh?
Rugrats?
I wonder if I can see this.
Good stuff. Good
That one
stuff.
question pushed you up. That last one pushed you
Did
up.
that help?
I was like,
It's
That helped
in high
him.
school.
What did we
I didn't even
learn?
look at that.
No, what did you learn?